In this problem, we are asked to determine if the curved arrows create a violation of some sort. We're supposed to be sure to count the lone pairs and the hydrogen atoms. So we've got this curved arrow here written, and let's try to draw what we would have. Now remember, carbon is tetravalent, so there's two hydrogens on this carbon here. Let's go ahead and draw what we've got. So in this situation, it's not, too terrible that we don't have an octet on this carbon. But what's really bad is this carbon here has 5 bonds or 10 electrons. And nitrogen never has more than 8 electrons. So that's a violation. Let's look at this problem here. We have a curved arrow pointing up to the oxygen. And in this case, we have a carbon that does not have an octet, but that's satisfactory as a curved arrow. Okay. In this case, we have a curved arrow shown. Now it's important to draw the hydrogens. On this carbon here, we have 1 hydrogen. And so there's going to be a formal charge of +1 on that carbon and a formal charge of minus on this carbon. And again, it's not too bad to have a carbon with less than 8 electrons, but it's definitely bad to have a carbon with greater than 8 electrons. So that's a violation. Let's look at this problem here. So again, let's draw in the hydrogens. The lone pairs are drawn for us. So again, it's not too bad to have a carbon with only 3 bonds or 6 electrons. That's a violation of the octet, but that's possible for carbon. And what's really bad here is that this oxygen atom has 10 electrons, and we never exceed 8 electrons for the oxygen atom. So that's definitely a violation. Let's look at this problem here. So we got these carbons drawn out, these lines to, methyl groups and stuff. So let's draw the structure that results from this. So the formal charges would be plus on this oxygen and minus on this carbon. And I put the lone pairs incorrectly there. Let me fix this. Yeah. Okay, so oxygen is okay. It's got 3 bonds, 1 lone pair, and a formal charge of +1, so it has an octet. That's fine. But what's bad here is this carbon here. We can never exceed the octet on carbon, so that's a violation. Here's another curved arrow. It appears to be fine, but let's draw in the carbon atoms and the hydrogen atoms that are involved in this. And when we draw the resonance structure, making sure to include all the hydrogens, we can get a better look at what's going on. So this carbon has 6 electrons, but that's fine even though it violates the octet. What's really bad here is this carbon atom. It has more than 8 electrons, and you can never violate the octet on carbon by having more than 8 electrons on carbon. Let's draw this resonance structure here. So again, let's pencil in these carbons and the hydrogens that might be nearby to get a better look-see at what's going on here. Now, in this reaction here, or this whatever curved arrow move, this bond in yellow is going to break. Okay, so we break that one, and we're going to form a pi bond there. Okay, so the 2 electrons are going to go from that carbon-carbon single bond highlighted in yellow and go to the carbon-carbon bond in blue to make a pi bond. So let me try to draw that in here. I'll try to use my color coding here. So the yellow bond was broken, and so, I don't need to show that. But the blue, I'm trying to keep blue. So if you look at this carbon here has 6 electrons, so we're not exceeding the octet, so that's okay. Everything else is fine in the molecule. The main problem is this carbon here. This carbon here has more than 8 electrons, and we can never exceed the octet on carbon, so that's a major violation. Here's another molecule. Now we're not moving pi bonding electrons once again, we're moving an actual sigma bond. So let me highlight again what's going on with this. We're actually going to break this carbon-carbon bond, shown in yellow, and those electrons are going to form a pi bond between these 2 carbons in blue. Okay, so we're going to form a pi bond there. So let me try to draw an arrow, a reaction arrow maybe. It's definitely not resonance. Now if we draw the 2 fragments here, we're going to have the fragment on the left, and that yellow bond breaks, so we're going to have like I said, a double bond between these 2 carbons. And we've still got those 3 hydrogens there. So we've got a carbon that has less than 6 electrons, so it's okay there. Not the best, but we'll actually see this acylium ion later on in the class. The major problem here is this carbon here. It has 10 electrons. You cannot have 5 bonds on carbon. You really want to avoid that at all costs. Here's another problem. The C's drawn in, there's no H's on that carbon, and the lone pairs are drawn in on nitrogen. So we'll go ahead and sketch in what this forms. So the pi bonding electrons are moving to the nitrogen, so we get 2 additional electrons. Formal charge is going to be minus on that, and the carbon is going to have a formal charge of +1. Okay, so this is decent. This does not exceed the octet, so that's fine. This still has an octet, so that's fine. So this is a valid resonance structure for a nitrile functional group. All right, let's read the curved arrows here. So we got this CH3 group here. We got this nitrogen. So we're going to be removing this pi bond and moving those electrons to this nitrogen atom. The other 2 bonds remain. Okay. And we want to go ahead and pencil in now what we have. So that's it. So let's count electrons carefully. 2, 4, 6, 8. This has 8 electrons, so it has an octet. The nitrogen on the right has 2, 4, 6 electrons. 6 electrons. Okay, so that's a violation. I've never seen nitrogen with 6 electrons. It's extremely rare if it is formed. It's generally not something you want to draw in organic chemistry. Let's look at this molecule. Again, let's pencil in the carbon and the hydrogens there. Let's try to draw what this makes. So we're moving one of these lone pairs to make a pi bond, and this is, this is just a CH3 group. R means alkyl. Don't worry too much about it. Let's count the electrons. 2, 4, 6, 8. 8 electrons here for oxygen, and this has 5 bonds. 5 bonds is really bad. So you don't want to ever draw 5 bonds on carbon. All right, let's consider this curved arrow. There's a CH3 group there. And if I try to draw what becomes of this, those 2 electrons in that nitrogen lone pair are going to be moved down to make a pi bond between the nitrogen and the carbon. Let's put in our formal charges here. And the main problem here is that carbon has 5 bonds. And you don't want to do that ever.